So in this problem, it asks us to multiply. So if we were to multiply, 1 times 18.16 would be 18.16. And then the denominator, 4 times 1 is 4. So we can divide. 4 fits into 18 4 times. 18 minus 16 is 2. Make sure your decimal spots are lined up. 4 fits into 21 5 times. 21 minus 20 is 1. Bring down the 6. 4 fits into 16 exactly 4 times. So this would be 4.54. For problems 1 and 2, calculate the approximate circumference of the circle. Remember, the word circumference is like the fancy circle version of a perimeter. So if we were to unroll this, how big around do you think that circle is? In the previous lessons, we found that the circumference is about 3.14 times the diameter, and the diameter is how far across the circle it is. So across the circle is 1, so this would be 3.14 times 1. So the circumference is about 3.14 units. Here the diameter, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3.14 times 10 is about 31.4 units. Here it gives us the ability to unwind that circle. And you can see that it ends up just a little bit past 3. And it's a little bit past 3, but not quite to 3.2. So there's that 3.14 approximation that we've been using. So it's in between 3.14 and 3.142. And we'll continue to zoom in and zoom in. And it's never going to line up perfectly on any of these place values. So even if we have 1, 2, 3, 4, 5 decimal spots, it still isn't lined up perfectly. So we can say it's about 3.1415. It's in the middle, so maybe 159 as our approximation. And then in number 3, it says use that approximation to calculate a better approximation for problem 1. Well, the diameter in problem 1 was 1. So that would just give us a circumference of 3.14159 units. And then it says use the approximation to give us a better approximation for the circumference from problem 2. The diameter in problem 2 was 10. So the better approximation would be 31.4159 units for problem 2. In the previous lesson, we were looking for some kind of relationship or constant of proportionality between the circumference and the diameter. And we found that it's about 3.14, but that value actually has a name. What do you notice about this number? You can see it starts with our approximation, but then it continues on and on and on. There isn't any pattern to the numbers, and it continues forever. This pi, the value of pi, is that constant of proportionality between the circumference and the diameter. But it never stops and it never repeats. There's no repeating pattern to this value of pi. So instead of trying to write c equals all of these digits times the diameter for our equation, we use a symbol that represents this number, and the symbol we use is the symbol for pi. So we're going to use a symbol that has a little squiggly top and then lines underneath to represent this value here. So instead of it being c equals 3.14159.265 and just continuing on and then times the diameter, we're going to use c equals pi times the diameter. Or you might also see it written as diameter times pi, because commutative property says we can switch the order when we have numbers multiplied together. This pi symbol is a Greek letter, and it's approximately 3.14, which is why you'll see this is a very common approximation that people use. But if we want to be more precise, we can just leave the symbol, similar to how we leave a variable in an expression. And pi is that constant of proportionality that comes from dividing the circumference by the diameter. So this says determine the circumference of the circle in centimeters. So we're going to have to start by measuring our diameter in centimeters, and then we're going to multiply it by pi. So with your ruler, you'll measure from here across the circle, and you should find that it's 12 centimeters. So if we replace the diameter with the number 12, 12 times pi has an approximate value, but if we wanted to give an exact value, we would write it like we would if we had x times 12, and we would say it's 12x. So just like with that pi symbol, we'll just write it as 12 pi. In your book on page 201, you have a circle with some directions. In recent lessons, we have discussed the distance around the circle, which we talked about as circumference, and we also talked about the area, which was the stuff inside the circle. What do they have in common? Well, both were difficult to measure with the tools that we had already. We just introduced pi to help us figure out the distance around the circle. But originally we were only able to get approximations for both the circumference and for the area. What are some things you might wonder about the area of a circle? Is there an exact area, or are we only going to have approximations for that as well? We're going to start by coloring the portion of the circle above the diameter one color. So you're filling in this section with one color. Then color the portion below the diameter a different color. So I have pink and yellow. Cut along the dotted line to separate the circle from the directions. Keep the directions for reference and cut out the circle. Fold the circle in half along the drawn diameter. So you're going to fold it here. So it'll look something like this. This outer edge here is the diameter. This is creating a semicircle. The next set of directions say to fold the circle in half along its radius. So now we'll have a piece that looks like this. This would be a quarter circle. For a quarter circle, this would be 1/4 of the diameter, and then we have 2 radii here and here. Then step 6 says to unfold the circle and cut along each of the folds. Oh, before we do, we have one more step. We're going to fold it along the radius a second time. So fold along the radius once and then a second time. So it will look like this. Then unfold it and cut along all the folds. When you unfold it, you should have several sections. When you cut it, you should have these triangular shaped pieces. And we measure along the radius, and we found that it was 6 centimeters because the diameter was 12 centimeters. So when we have the radius pieces here, those are each 6 centimeters. And we should have 8 pieces, 4 of each color. We know that the circumference of the circle would be 12 pi because the diameter is 12. So all of these pieces along the bottom will have a sum of 12 pi. But we're still not quite sure about the area of all of these pieces. If we rearrange the wedges to create a more familiar shape, now instead of 12 pi across the base, I've split it so that I have them half on the top and half on the bottom. So I'll have 6 pi on the top and 6 pi on the bottom. It's starting to look more rectangular, but I can take it even a step further. If I cut this piece here and move it to the other side, I can get more of a rectangular shape out of it. Now I have a shape that looks like this. It's still going to be 6 pi along the bottom. And this distance here is also 6 centimeters because it's from the center of the circle to the outside edge. So this is 6 pi as the base and 6 as the height. So if I was finding the area as if this was a rectangle, I would do 6 pi for the base times height, which is 6. Another way you could rewrite that is 6 times 6, which is 6 squared pi. And 6 wasn't the diameter, it was the radius. So we can use this formula for finding the area of a circle. So for this specific circle, it would be 6 squared times pi, and 6 squared is 36, so this would be 36 pi, and we would measure it in centimeters squared. So the area, all of this shaded sections, the green and the pink, or the yellow and the pink, adds up to 36 pi centimeters squared. So that's the area to fill in the whole circle. So here's kind of a virtual representation of what we just did. So step 1 was we split it in half. Well, we cut it in wedges first. We did 8 wedges. Then we cut up all of our wedges and put them together. And we had 6 along the bottom and 6 along the top. So our base was 6 and our height was 6, or our base was 6 pi and our height was 6. If we use even more and more and more wedges, it starts to look even more like a rectangle. So that approximation, it still has half of the circumference, which the circumference was diameter times pi. And if we cut the diameter in half, that gives us a radius times pi. And then these wedges are a radius tall. So the area will be radius squared times pi. it says in step or problem 5 to tape your final product into your book. So you're just taping those wedges into your book. And then determine the area, which we already did. We said that was 36 pi centimeters squared. And so the area of the circle is also 36 pi centimeters squared because our wedge figure was made up of pieces from the circle. Determine the approximate area of a circle in problem 4 by using 3.14 for pi. So if we had 36 pi, now we're replacing the pi with approximation 3.14. So we will multiply. 6 times 4 is 24. 6 times 1 is 6. Plus 2 is 8. 6 times 3 is 18. 3 times 4 is 12. 3 times 1 is 3. Plus 1 is 4. 3 times 3 is 9. We have 2 decimal spots there, so we need 2 here. So the area is about 113.04 centimeters squared. That's the end of lesson 12. We'll continue working with finding circumference and area of circles in the next few lessons.